In today's lesson, we're going to learn how to solve linear equations. And a linear equation is an equation that has the highest degree term as a first degree term. And let me just give you an example of exactly that. So if we had 3x plus 4 is equal to 1, this is an example of a linear equation. We have our highest degree term, which is right here, and the degree of this highest degree term is first degree because our x here is raised to the power of 1. And you'll recall a few videos ago we went over what is meant by the highest degree term and what a first or second or third degree term is. And basically the degree of your term is just the power that the term is raised to. So when we're dealing with linear equations, we're going to have the highest power of x as x raised to the first power. So let's actually look at how we would solve an equation like this. Now, when you're given a linear equation, the best way to solve those equations is to rearrange your equations so that all of your constants, and those are going to be things like this and this, these are your constants. You want all of your constants to be on one side of the equation, so on one side of the equal sign. And you want all of your terms that have the variable in it, so this is an example of a term with the variable in it. You want all of the terms with the variables in it to be on one side and all of your constants to be on another side. So the way that we can rewrite this is to keep all of our variable terms on one side, so we'll have the 3x remaining on this side. And now we want to move this plus 4 to the other side of the equal sign. And you'll recall that when you are moving something from one side to the other, you have to switch its sign. So our 1 is remaining on the same side that it was, but now we're moving this plus 4 to the right side of the equation, so it's going to become a minus 4. And now we can solve either side, so 3x is equal to 1 minus 4 is negative 3. And now to solve for x, we have to divide both sides of the equation by 3. So if we divide both of these by 3, we're going to be left with x is equal to negative 1. And this is going to be the strategy that you're going to use every time you are trying to solve a linear equation. You are going to keep your terms with a variable on one side of the equal sign. You're going to move all of your terms without a variable or your constant terms to the other side of the equal sign. And then you are going to simplify and solve for your variable. So let's go over a few more examples to make that even more clear. Let's say you are given this equation. So when we look at this equation here, the first thing that we want to do is we want to expand this out so that we have all of our terms in the most expanded form possible. So let's actually multiply this 8 into these brackets here. So 8 times 3 is 24, so we're going to get 24x. 8 times minus 2 is going to be negative 16. And then we have our minus 2x here, and this side of the equation is going to stay the same for now. And now we can see that we have some terms with variables on this side. And we also have a variable term on the other side, and we have a constant term on this side and one on this side as well. So what we want to do is we want to get all of our terms that are circled in green on one side of the equal sign and all of our terms circled in red on the other side. So we're going to keep our variable terms on one side and our constant terms on the other side. So let's keep this 24x here. We can also keep this minus 2x here. Let's bring this minus 6x to this side, so it would become plus 6x. Then we have our equal sign. We are going to keep our 3 on this side, and now we want to move our minus 16 from the left-hand side to the right-hand side, so it's going to become plus 16. And now we've rewritten our equation with all of our variable terms on one side and all of our constant terms on the other side. And now we can just simplify this. So 24 minus 2 is 22. Plus 6 is 28, so we're going to be left with 28x here, and 16 plus 3 is equal to 19. And now if we want to solve for x, we're going to have to divide both sides by 28, and we're going to be left with x is equal to 19 over 28. Let's go over another few examples. When we look at an example like this, we can see that we already do have a few terms with our variables on one side and a constant term on the other side, but there isn't a quick and easy way to rearrange this where we can move some of our constants and some of our variables to keep them on respective sides of the equal sign. So the way that we're actually going to solve this here is to try and get rid of this denominator here, so we're not dealing with a fraction anymore. And the way that we can do that is by multiplying both sides by 2x plus 4. So if we were to multiply both sides by 2x plus 4, let's say we multiplied this by 2x plus 4 and we multiplied this by 2x plus 4, these two would end up canceling each other out, and we'd be left with 1 minus x is equal to 3 times 2x plus 4. And now we can solve this by expanding this side out. So we're going to get 1 minus x is equal to 3 times 2x is equal to 6x. 3 times 4 is equal to 12. And now we can do what we've been doing in the previous examples. We're going to try to move all of our terms with variables to one side and all of our constant terms to the other side. So let's keep our 1 here. And let's move our 12 to this side of the equation. So this is going to become a minus 12. And then we have our equal sign. We're going to keep our 6x here. And now we want to move this minus x to the right side of the equation. So it's going to become plus x. And now we can solve. So 1 minus 12 is equal to negative 11. 6x plus x is equal to 7x. And if we want to solve for x, we're going to divide both sides by 7. So we're going to get x is equal to negative 11 over 7. Let's go over one more example. Let's say we had the following equation. 5 minus 7 over x is equal to 2 times x plus 4 over x. So at first glance, this looks like it might be a little bit complicated. But what we can notice is that already in 2 out of the 3 of our terms, we have x as a denominator. So if we got each and every one of these terms to have a denominator of x, it would be a lot easier for us to solve this equation. So we need to convert this 5 into a form where it has a denominator of x, but it still has to equal to 5. So what we can do is actually express this 5 as 5x over x. And remember, if we have this, these two x's are just going to cancel out. So 5x over x is the same thing as 5. So if we write this as 5x over x, then we have that minus 7 over x, and set that equal to 2 times x plus 4 over x. And now we can see that each one of our terms has a denominator of x. So we can write down this side as 5x minus 7 over x, and that is equal to 2x plus 4 over x. And now, because x is a denominator in both of our terms, we know that just these numerators have to be equal to one another in order to make this equation equal. So if both of these have a denominator of x, then 5x minus 7 has to be equal to 2 times x plus 4. And we can expand this out. Let's just write this in its expanded form. That would become 2x plus 8, because 2x plus 2 times 4 is 8. And now we can do the same thing that we've been doing. We move our variable terms on one side and our constant terms on another. So let's leave our 5x here. Let's bring this 2x over to the left-hand side. So that becomes minus 2x. Leave our equal sign here. Well, we have our 8 here. And now we're going to bring our negative 7 to the right side, and that's going to become plus 7. So if we just give ourselves a little bit more space here, we have 5x minus 2x, which is 3x, and that's equal to 8 plus 7, which is 15. And now to solve for x, we're going to divide both sides by 3. So x is equal to 5.